Yeah, well, this is great. Thanks for joining the party. The .NET Conf is not done yet, and we're excited. I'm going to be bringing on Robin, and Robin, you are going to be blowing our minds with some cool stuff. So uh, you're going to be teaching us about using ANTLR to parse text.
Yeah.
Is that right? So that sounds amazing. I've read about ANTLR and been scared off every time I've looked at it.
Oh,
And
no.
I've also written text parsing code that I'm sure my code has scared other people. So I'm excited to see you teach us the right way to do this.
Okay, well, let's start. We're going to go, like you said, crashing through some code here.
Wonderful.
So let's start.
You
So
can
I'm
hit the,
Rhonda.
sorry, but before you get into it, hit that
Okay.
little hide thing down at the bottom.
Oh, got it.
And yeah, that'll free it
Okay.
up. Awesome.
Is that better? Okay. So I'm Robin. I'm a content PM at Microsoft. I work on Dynamics 365, and I work on developer content for the product. And recently I had a bunch of content in Markdown that I needed to move to XML. And also recently I'd taken a compiler class at Georgia Tech. And so I said, well, you know what? I think I can use ANTLR for this. So let me give it a try. And let's go on to the next slide. So people mostly think of ANTLR as a parsing tool for programming languages, but you can actually parse any kind of structured content, text or binary files. And you can find sample grammars for all different kinds of languages. And I even found one for Morse code. I didn't find one for Markdown. So I decided I would use it to solve my little problem. So first, let's look at a really basically simple case of using ANTLR before we get into the full thing I had. So the basic workflow is you create a grammar. It's a little file that describes your language or your content. And you run it through ANTLR. As they say, that's basically a command line program. You say, ANTLR, here's my grammar. And it spits out a bunch of code in Java, C#, Python, whatever language. I decided to use C# this time. And you get a number of things. The one we're going to work with is the lexer, the parser, and the visitor. And so what are those and what do you do with those? So you take your input. In our first example, we're just going to take 4 plus 5. And you run it through the lexer and it creates tokens. And tokens you can think of as little chunks of content, words basically, words and punctuation. And then you send that to the parser, and the parser understands how those tokens fit together, how 3 different tokens create, say, a variable declaration or a function header. And it runs through all your input and it creates a tree for you. And so then what you do is you visit your tree. You basically look at each node in your parse tree, and then you spit out whatever it was you really wanted. So in this case, we're going to look at 4 plus 5, and what we really want is 9. So what does that look like? So on the left, you can see the grammar that handles this case, and on the right, you can see the parse tree that's created. So we're starting at kind of the bottom of the grammar. You kind of build up. On the one hand, your tree is created. You think of it top down, but you also kind of work from the bottom up. So first, we're going to ignore white space. I don't care if there's a tab or a space between 4 plus 5. And then what I know is I have integers, and then I have a plus sign in between. So those are the tokens I'm going to create. And then I want to, and those, we also know those are lexer rules because they're capitalized. It's a convention in ANTLR. And then we start making our parser rules, those things that we build the tree, that we actually build the tree out of. And so we really only have one parser rule in this case, and that's the equation. It's an integer, a plus sign, and an integer. And we call our entire grammar addition. It has to have a name, it has to have a start location, and in that case, it's equation. So what does this look like once we get into Visual Studio? Let's go to Visual Studio. Okay, so here I've got a little C# program, and here's my grammar again, and it's not so colorful because it's not in VS Code. And so you run ANTLR on it. It creates a bunch of C# files. It also creates a bunch of Java files. And then you just compile those, and now you can run the test harness. I can show you how that works. Then you simply run a little command, and you tell it, I want my addition grammar and the equation rule. And here's some inputs, 4 plus 5. And then you just enter that. And you wait a second. and you get this a nice little tree inspector, and you can click on things and see the whole thing. And that's really handy. I haven't had to write any C# code yet. I just wrote my grammar, and now immediately I can test it, and I can start working with it and get the tree to look like what I think works for what my problem is. So now I created a C# application so that I can now do something. Now I've parsed it, and now I want to get my number. So what I did is I created a C# console app using the .NET framework. I added a reference to ANTLR using NuGet. That was pretty simple. And then I just added all those C# files straight off the disk. And so what I've got is like I said, a lexer. So these are generated, which means you don't want to change these, because every time you go back and change your grammar, they get regenerated. So you just want to leave those alone. Then there's the parser we talked about. There's also something called a listener, and we're not going to talk about that today. And then there's a visitor, which is an interface. And you say, oh, what do I do with that? Well, they also give you an implementation of that interface. But again, this is generated, and you don't want to touch it. So what you do is you create a class that inherits from the base visitor. And that's what I've done here. And this is where my work goes. So I called it calculator because it's going to add 2 numbers. And it derives from base visitor. And it's going to return an integer because we're going to take those strings, we're going to convert them to integers and return the sum. And we only have one rule, so that it creates one method. We're going to visit the equation as we're going to visit each node. And then it has a parameter called context, and the context knows about all the things in that rule, and that rule had a couple of integers and a plus sign. And so we just grab the 2 integers, basically. We turn them into, well, they're 2 strings that have digits in them. We turn them into integers, we add them up, and we return that value. So now how do we get the output? How do we get that number back? So here's sort of the basic plan when you're running ANTLR. And if you think back to that workflow, it fits right in with that. I've got some input, got to turn it into a character stream. I need to create my lexer. I give it that stream. Then I want to create tokens out of it. And so I create a token stream and give it my lexer. Then I take those tokens and I can create my parser, because remember, we feed the tokens into the parser. And then I basically visit equation in the parser, and it builds the tree. So now I've got a tree. So then I send that tree over to my calculator. So I create, I just create one, instantiate it. I visit it, so it starts at the top. It starts at equation, visits equation. And then, we return that integer. So now our integer should be right there. And then we can just do a write line. So let's run that and see what happens. And there we've got it. 4 + 5 = 9. Exactly what we thought. Okay, so that was kind of interesting and fun and short. So what was our real issue? So the real issue was I had a lot of Markdown, and I needed to get it into XML. So let's take a look at what those files look like. So I'm going to go over here. So this is what our content used to look like. We had a file. It had the name of the class. It had the syntax, the syntax for the object. There were some remarks. Sometimes there would be a little short summary right here. There were examples with code. There was a list of the methods. And then there was a heading for each method. We listed each method and its parameters and its return value. And we had a little tiny table of contents, but they weren't really connected to each other. So if I had a parameter that was, say, an integer, it didn't connect to the integer class so that you could go learn about integers. And they weren't arranged by namespace. So I wanted to pull that in together. And then this is what it looked like, quote, underneath. This is the actual authoring markdown that we used. There was a header at the top with some publishing things for search and who owned it and whose work it is. And then here's the content in Markdown. I don't know if you're familiar with Markdown, but it's basically a plain text way of creating content. So there's a lot of pound signs for headings. And then you use these bars to create tables. So the content was very structured because we had previously created it from a tool. And so I thought, well, this might work. There's one little thing we had to keep track of, though, is that code is specified in Markdown by being indented. And that's going to come back later in this process. So that's what we started with. And this is the new content we have. And because the new tool actually reflects over the DLLs, it gathers all that information about inheritance, and we make sure we have all the current properties and methods, and everything links to each other. You know, I have the overloads. I can click off into the .NET framework because our APIs are all managed. So we get a lot of that. And, you know, we again have our small table of contents here. We can see up here which namespace we're in. And then every time our DLLs change, we could rerun this and it updates all the properties and methods and stuff. So we really wanted to move over here. So then we looked at, well, what does that authoring look like? So let's get a little bigger here. And so that's all in XML. And then the documentation is in some of these tags, but this doesn't format as well as we can find it over here. So let's go look in Visual Studio Code, and this is the same file. And so you can see there's lots of stuff. There's the name of the class and all the different type signatures for the different managed languages. And then we have a docs element here. This is at the class level, so each one can have a summary. This one was empty. It can have remarks, and that's where we put not only the remarks, but also the example sections. And then I notice another thing we did was, instead of just using indenting to mark code, we actually used what they call fencing, which are the 3 backticks. And then we put XPP here, and that gets us code highlighting that's specific to X++. So that's what we wanted to do. So we looked at the Markdown, the format. So I just parsed it with ANTLR. So let's take a look again over in VS Code. VS Code here again. VS Code has a nice extension for syntax highlighting of ANTLR. There's also an extension for Visual Studio, but I haven't installed that yet, just because I haven't. So here's the grammar. What I like about the ANTLR grammar is it kind of looks like your content that you're trying to parse. So here's the input file. We did a little pre-processing because it was worth doing a little pre-processing. We took out that header at the top. There's no need to, since it was so easy to remove, we just removed it. We didn't need any of that information. It turned out to be a little tricky, actually, to deal with those multiple pound signs. There was 1 pound, the heading 1, 2 pounds for the table and each method, and then 3 pounds. So it was actually pretty easy to go through and put words in there that were really easy to find and were really easy to parse on. And it turns out there wasn't really a huge amount of different things in the file. We basically got, we had the class name and a little summary about it, maybe some remarks and an example, and then several methods, and each of them had maybe a summary and remarks and an example and parameter names and descriptions. And that was basically it. So you can see we've only got about 14 or 15 different rules here for those things. And almost every one of them has something called content. And that's basically the documentation, the markdown that we wanted to pull out. And so content is ID, which you can think of as word, plus a whole bunch of different punctuation, and then some special words we needed to capture because they were often used in the signature, the method signatures. So those are the rules. And then there's some Lexer, things going on down here, some tokens, just to deal with the punctuation and the names. So that's what the grammar looks like. It's fairly simple when you get down to it. Let's go. So here we go. And so back to the demo, right? So now we'll go back to Visual Studio again. So there's the grammar. Again, we've got our lexer, our parser, our lexer, our parser. The listener we're not going to use. We've got the visitor interface and the base visitor. And then I created the listener, the custom listener. So the plan was I would parse up the markdown, and then I created a class called system class, and it basically held all the information I took out of the markdown. So using the parser, I could find all the different pieces of documentation I need, and then I put it in this class after it's all been, I fixed all the code and everything. And then after I've gathered it all up, I've got to write content. I send in an XML document, and using XPath, standard kind of XML XML handling in the .NET framework, I could just inject all those bits of markdown into the XML, which was really pretty easy. There's not even a lot of code there. So that's the system class, and the system includes a bunch of methods. The class, includes a bunch of methods. So that means most of my work was in the what I called the topic visitor, which again inherits from the base visitor, and then you just override the pieces you need. Where was I? So when I open it, I send the system class so it can fill that in, and then I need to send the actual original content stream, and I'll talk about that in just a minute. And then I visit the top node. And so this is, once you start visiting the nodes, this is where you have to decide how you're going to visit all your nodes. There's a method called visit children. You could visit this node and then do the work and then say, go visit all my children. And then the children do whatever they need to do. So in this example, the class is at the top, and then it's got methods, and you can visit those. I should show you one of those. And so the work goes on here. So you have to decide, are you just going to go straight down the tree, or do you want to have more control in the sense that I'm not just going to let it go visit whatever it wants recursively. I'm going to see if there's a summary. I'm going to see if there's examples. I'm going to see if there's methods. And so I've written code to do those specific things. So if there's an example, I'm going to go visit it. If there's remarks, I'm going to go visit it. And if there are any methods, I'll go visit those one by one. So what was I going to say? Oh yeah, so while I'm here, let me show you. So remember we were looking at, I think it was field binding, and we had the grammar. It's all been compiled. We can run this little test tool, and we can see the entire class here as a tree, the entire file. And so, like I said, it wasn't very complicated, so it isn't very deep, but it's very wide because there are a lot of methods. But fortunately, we can go over here and we can navigate through and just see one method at a time. So here's the pack method, and we can see it's pack content, and here's a little string of some documentation, and then it's got the method signature, it's got a return value, and here's a little bit about the return value. So we can check our grammar to make sure it's okay that way. So anyway, there was one other thing I wanted to mention about going through this that was kind of interesting, because basically, you look for the remarks and the examples, and you look at each method, and it has remarks and examples. So remember I talked about the actual markdown itself, and it turns out that markdown formatting matters. So it matters where the carriage returns are. It matters when you have tabs and spaces, and it matters about vertical bars. And so you can't just, remember we stripped out all the white space, which means all we get in the parse tree are all those individual tokens. And when you have code, it's just basically an array of parentheses and curly braces and semicolons and words. And so I need to go back and get that markdown back, the actual markdown. And so it happens when I want to visit, say, especially examples, because the example section has that indented code. is I go and I visit the content. Go to definition. And from there, using the original string, because we passed that in when they build it, you can look at the beginning and the end of that node and get all the content that was there originally. And it turns out, in my class, we also, we parsed the whole language, and it was surprising how many times we kind of had to go back and get the original content, even though we parsed it. So maybe we weren't, quite there yet, but it comes up. If you start using it, you'll end up on Stack Overflow wondering how to do that. So then once I had the original content, then I could parse the example. I wrote a little method to do that. Go to the definition. And so once I had the original, I could go through, and where I found indentation, that meant it was a code example, and I could add the fencing around it and do that. Another way to handle it, I could have written a second grammar, and then I could have passed my original string to a second grammar, and maybe that second grammar wouldn't ignore the white space. And in that case, I might be able to get that information without having to, again, here back we are parsing, strings again, and do that. So we've run through everything. Let's take a look. So now we can run it. So we go over here to, where are we? Looking for program. It's console app. I call it program. It's a lot of housekeeping and a little bit of ANTLR. So down here in the middle, again, we saw that in the example. You create the lexer and the parser, and you send the tokens. And the rest of the code basically just opens up all the files and finds the XML file that goes with each markdown and fills it in and saves it out. And then, sometimes things don't match up, and it creates a list of problems, and also a list of who's going to have to review them, because we had 475. So we can run it, and it's going to go through 30 or so, at least it did earlier today. Not all that necessarily exciting to watch it run. We can go see that the file updated right now. We can open it up in let's open it up in Visual Studio Code, because it has nice highlighting there. And you can see here's my new code added in here in Docs. And that's basically it. That's the way it goes, kind of the crash course. And so the work was done fairly quickly. It was a lot of fun, I thought, rather than like having to grind through a lot of string manipulation code, which I actually like. But I thought this was a lot of fun. So here's some resources. There's a lot of sample grammars out there on the internet. There's the C# target, they call it. The ANTLR book is great. Highly recommend it. And it's on O'Reilly Books if you have a subscription to that. So questions?
Wow. Yeah, that was fascinating. Let me see. So we had just one come in, and a reminder to people watching, ask your question using .NET Conf, and not only will you get it answered by these brilliant speakers, but you will also get entered for fabulous prizes in a drawing. So this was a question about converting from XML to JSON.
Okay.
And yeah, I don't know. I could see that you could do that. I guess there's other ways also that you can convert from XML to JSON. What would your thoughts be on that? So
first of all, I know if you go to the sample grammars, you can find a grammar for XML, and you can find one for JSON. That's probably not the way I do it, because you can read XML. There are XML readers in the .NET framework, and there are JSON readers. So you could create an object that goes in between and save them out. You could certainly do it. And it's interesting, because I had talked about whether you should walk through your nodes purposefully, or whether you should kind of let it go recursively on its own.
Mm-hmm.
And XML is a format where I think letting it go recursively on its own kind of works, because everything has to be properly nested. So that would be interesting, yeah.
I personally thought that was fascinating. Normally they talk about how crazy it is to try and parse HTML, because it can be all kinds of crazy stuff. But Markdown is kind of scoped down in a way that like you were able to make it work. Did you run into problems with escaping or any kind of, like weird edge cases?
Oh yeah. Okay. Do you want to actually see that code?
Sure, why not?
Okay. So let me see if I can find it. Yeah. So there's some issues because obviously, um, Markdown handles like greater than and less than differently than
Yeah.
XML, and um, we don't escape it. No, sometimes we do escape it in Markdown. So somewhere in here, let's see if I can find it. I actually was able to call some functions from the .NET framework to handle it. But just oops, I'm in the wrong file. That would help. It's down here a ways. I'll try and find it. Remove empty. But yeah, I had to deal with that.
Yeah.
Sorry, I try and find it.
Well, and like a lot of parsing logic I've had to write, sometimes you're like, do I do it the absolutely perfect way, or do I just find this one little character that always fails and replace it with the right thing?
Right. And I'm looking for it and I don't find it, but I remember working on it, and I actually removed some comments related to it right before we started. Because remember, I also ended up putting it in C data tags.
Uh-huh.
And once you put it in C data tags,
anything goes there, right?
Yeah, you don't have to deal with it. But I did go back and forth a few times trying to get that to work. Yes.
Okay. Had one other question come in. What's the wildest application of ANTLR you've ever seen to parse what kind of text? I mean, maybe you've got the wildest application of ANTLR right there.
I don't think this is the wildest. Oh, no, I don't know if I have an answer. I know you can parse binary inputs as well.
Okay.
I suspect there's, somebody parsed images, if I had to guess.
Wow.
And that could be interesting to look at how you would do that and what your tokens would look at, what your Lexer would look like to do that.
Wow. Wow. Well, that was
powerful. We've only touched, on what it can do.
Yeah, I think this is great. Like, it's a really practical application, and it's also a great way to kind of expand my thinking. And viewers thinking of ANTLR is not just a cog in the writing a programming language, like a traditional programming language, but it's useful for exactly the kind of thing you did.
Right. And it was a lot of fun because a lot of people, I think it's mostly Java. It's basically a Java task, but there's so many targets. There's even Python. I was using Python at the hackathon last summer. Yeah, it's very flexible and powerful.
Awesome. Great. Well, thanks a lot. So we'll say goodbye to you and thank you very much.